You know, when you think of the ultimate, like, cutting-edge injury healing elixir, you probably picture something cooked up in a sterile, high-tech lab.
Right, yeah, like some glowing neon green liquid in a vial.
Exactly. Or, I don't know, maybe some exotic, newly discovered plant extract from the depths of the Amazon or something.
You definitely don't picture the stuff currently churning around in your stomach after eating a cheeseburger.
No, you really don't. But that gastric juice is exactly where the fitness world's most controversial healing compound comes from.
It's pretty wild.
It is. Welcome to today's deep dive. We are looking at a compound that has the fitness, bodybuilding, and biohacking worlds absolutely buzzing. We're talking about BPC-157.
A very popular topic right now.
Oh, massively. And our mission for you today is simple. We're going to separate the internet hype from the actual biological reality.
Which is desperately needed, honestly.
Definitely. So we'll look at what this compound actually is, how it alters the human body, its legal status, and, why it is absolutely crucial to understand the very fine line between accelerated recovery and an unproven miracle.
Yeah, that line gets blurred a lot.
It really does. Okay, let's unpack this because the sheer irony that one of the most highly sought-after fitness compounds originates from proteins naturally occurring in human stomach acid is just too good to ignore.
It is quite the origin story, truly.
Hey.
To really understand BPC-157, we need to focus heavily on its regenerative signaling and tissue protective effects.
Right.
If we strip away the bodybuilding folklore for a second, what we are looking at is a synthetic peptide. It is created in a lab, yes, but its molecular structure is derived directly from a naturally occurring protective protein found in gastric juice.
Which raises an immediate question for me. How does something that evolved to help digest food end up being injected by athletes trying to heal a blown-out knee?
It sounds like a leap.
Let's dive into the mechanics. When we look at the clinical data, BPC-157 operates as this master coordinator for tissue repair. How is it actually doing this on a cellular level?
Well, it comes down to a few core physiological mechanisms. First and foremost is angiogenesis.
Angiogenesis.
Right.
Yep.
This is the biological process through which your body forms entirely new blood vessels from pre-existing ones.
Okay.
And BPC-157 heavily upregulates this process. Then it interacts directly with your nitric oxide pathways.
Nitric oxide, which is like a vasodilator, right?
Exactly. It relaxes the inner smooth muscles of your blood vessels, causing them to widen. So when you combine those two actions,
You get a lot of blood flow.
massive improvement. A massive improvement in localized blood flow and nutrient delivery directly to damaged tissues.
So it's like widening the existing pipes and simultaneously building brand new ones.
Spot on, but it doesn't stop there. It also influences the expression of E04 genes.
Eager.
Yeah, these are specific genes that control the early phases of wound healing. So it's not just sending blood to an injury, it's actually flipping the genetic switches required for fibroblasts to start doing their job.
Fibroblasts being the cells that actually build tissue.
Yeah, they're the cellular workhorses. They synthesize the structural framework for tissues. BPC-157 gives them the instruction to rapidly start depositing type 1 collagen.
Which is basically the concrete used to repair the damage.
Exactly, the biological concrete.
I like to picture this like a city planner upgrading a highway system after a natural disaster.
Oh, that's a good way to look at it.
Right. BPC-157 acts like the planner who comes in, widens the existing roads using that nitric oxide, and then builds entirely new supply routes, which is the angiogenesis.
Yeah.
And because of all this new infrastructure, the repair trucks, the fibroblasts, they can get to the crash site infinitely faster to drop off the collagen and concrete.
That is a highly accurate way to visualize the cellular logistics, actually. It fundamentally improves the body's biological infrastructure for repair.
Wait, I'm stuck on something, though.
What's that?
If it's literally building new blood vessels, pumping in nutrients, and ramping up gene expression to build all this new tissue, why wouldn't my muscles just blow up in size?
The million-dollar question.
It seems counterintuitive. If I'm building more highways, I can build a bigger city, right?
What's fascinating here is that we have to firmly distinguish between the mechanisms of repair and the mechanisms of growth.
Okay, repair versus growth.
Right. BPC-157 mimics protective peptides to trigger a systemic healing response, but it is not an anabolic response.
Gotcha.
It entirely lacks the androgenic properties necessary for significant protein synthesis and, cellular hypertrophy.
Meaning it's not acting like testosterone or like IGF-1.
Far from it.
Sure.
Skeletal muscle expansion, the actual physical thickening of your muscle fibers, requires specific pathways.
Right, driven by hormones.
Exactly. Driven by hormones like IGF-1 and testosterone, alongside a surplus of calories and progressive overload from training. BPC-157 does not directly stimulate those hypertrophic pathways.
So it's not a muscle builder.
The clinical consensus is very clear that direct hypertrophy benefits are simply not proven. No controlled trials have confirmed direct muscle growth from this peptide alone. Expectations for muscle size gains from BPC-157 should remain entirely conservative.
But if it's not magically inflating skeletal muscle, why are so many massive bodybuilders absolutely swearing by it? I mean, there has to be a reason they think it's making them bigger.
Well, it comes down to how it alters the timeline of injury. It accelerates the transition from the inflammatory phase of healing to the proliferative phase.
Okay, break that down for me.
Sure. When you train intensely or sustain a micro tear, your body initiates a heavy inflammatory response.
Right, you get sore and swollen.
Exactly. White blood cells called neutrophils infiltrate the area to clean up cellular debris. But their aggressive nature can sometimes cause excessive secondary tissue damage.
Like they do too much cleaning.
Yeah, exactly. BPC-157 decreases that neutrophil infiltration. It neutralizes the inflammatory markers and simultaneously increases myoblast proliferation.
Myoblasts being the precursor cells, right?
Right, the precursor cells that eventually fuse to form muscle fibers.
So taking BPC-157 is like taking a super fast pit stop during a grueling race.
Okay, yeah.
It doesn't put a bigger, more powerful engine in your car. It just fixes the worn-out tires faster and changes the oil instantly.
That's exactly it.
You get back on the track sooner, allowing you to train consistently without being sidelined by nagging injuries. So the mass gains people see aren't from the peptide building muscle, it's from the fact that they never have to skip a workout.
That completely encapsulates the reality of recovery versus the hypertrophy myth. The gains are a byproduct of training consistency, not the peptide synthesizing new contractile tissue.
That makes total sense.
Yeah, the evidence-based pillars for actual muscle mass, like progressive resistance training, optimizing protein intake, getting adequate sleep, and utilizing established supplements like creatine, those are still non-negotiable requirements.
There are no shortcuts.
Right. BPC-157 only offers an indirect advantage by drastically reducing your downtime.
So, if BPC-157 is traveling systemically to heal a torn bicep or a strained quad, it's inevitably passing through other tissues. What happens when this repair signal hits a damaged tendon or like an inflamed gut on the way?
Yeah, let's look beyond the bicep. This is where the sheer versatility of the peptide becomes apparent.
Right, because we know it speeds up muscle repair, but what else?
Experimental research highlights its profound effect on Achilles tendon ruptures, for example.
Oh, wow. Achilles ruptures are brutal.
They are, and it significantly enhances the migration of tenocytes.
Tenocytes.
Tenocytes are specialized cells responsible for synthesizing the structural matrix of tendons, but they are notoriously sluggish.
Sluggish? How so?
Well, tendons have terrible blood supply compared to muscle tissue, which is why they take months to heal. By boosting angiogenesis and getting those tenocytes moving, BPC-157 helps the structural integrity of collagenous fibers in tendons and ligaments return much faster.
That is massive for any athlete dealing with joint pain. But it goes beyond the musculoskeletal system, right? Going back to its roots in, gastric juice.
Right, exactly. It acts as a powerful protector for the gastric mucosa. It can actually help heal inflammatory bowel conditions.
Wait, really?
Yeah, and it actually prevents the cellular damage to the stomach lining caused by prolonged use of non-steroidal anti-inflammatory drugs.
Wow. So it can essentially heal the gut damage caused by the high-dose painkillers you might be taking for that torn tendon.
Yes, it offers a dual-pronged recovery, and its reach even extends to the nervous system.
The nervous system, too.
Yeah, the data notes neuroprotective effects that mitigate damage after traumatic brain or spinal cord injuries, with nerve growth factors showing increased activity in the presence of the peptide.
That's incredible.
It is. Furthermore, it facilitates osteoblast activity for bone healing, meaning microfractures repair more efficiently. It promotes scar reduction in skin burns and even exhibits protective effects against liver injury and oxidative stress.
Okay, here's where it gets really interesting. If I have a gut issue, like an ulcer, versus a torn ACL in my knee, how does the body know where to send this stuff?
That's a great question.
Does it just flood the system and hope for the best, or can we target it?
The administration method dictates how the peptide is distributed.
Okay, so how you take it matters.
Absolutely. Clinical protocols generally detail two primary methods. subcutaneous injection, and oral capsules.
Right.
If you have an acute musculoskeletal injury, say, that torn ACL or a deep muscle contusion, a subcutaneous injection using a tiny needle near the injury site provides a much higher localized concentration directly to those damaged tissues.
You're literally dropping the biological construction crew off right at the crash site.
Exactly. But if you are taking it for systemic healing or specifically for gastrointestinal health, oral capsules are the preferred route.
But don't oral peptides just get destroyed in the stomach?
Normally, yes. Most standard peptides are incredibly fragile. They get utterly destroyed by digestive enzymes and stomach acid before they ever reach the bloodstream.
Right, that's what I thought.
But because BPC-157 inherently originates from gastric proteins, specialized molecularly stable versions of it can actually survive the hostile environment of the GI tract.
Oh, that makes so much sense.
Yeah, oral forms work exceptionally well for resolving gastric issues, though they provide much slower, diluted results for localized joint or muscle repair.
You match the delivery vehicle to the destination, which brings up a broader question about the peptide landscape, because BPC-157 isn't the only string of amino acids biohackers are experimenting with right now.
No, not at all. It's a crowded field.
When you look at the comparison data between BPC-157 and other recovery compounds, how does it stack up against the rest of the pack?
Well, it's highly specialized. For instance, you will often see it compared to TB500.
TB500.
And TB500 is actually superior to BPC-157 when it comes to something called actin sequestration.
Actin sequestration, which means what exactly? Because that sounds like a financial term, frankly.
It does sound a bit bureaucratic, I'll give you that. Actin is a vital cellular protein that forms the structural scaffolding or the skeleton of your cells.
Okay.
When a repair cell needs to migrate toward an injury, it has to constantly break down and rebuild that actin skeleton to physically crawl forward.
Like it's pulling itself along.
Exactly. Actin sequestration is the process of binding to those actin proteins to keep them fluid and available. TB500 excels at this, massively speeding up how fast repair cells can migrate through the body.
Making it excellent for systemic flexibility then.
Yeah, and wide-ranging tissue repair.
Oh, wow. So TB500 is essentially giving the repair cells a high-speed transit pass to move around the body faster.
That's a great analogy, yeah.
What about peptides like ipamorelin or CJC-1295? Because I see those mentioned alongside BPC all the time online.
Those operate on a completely different axis. Ipamorelin and CJC-1295 are growth hormone secretagogues.
Meaning they secrete growth hormone.
Well, instead of injecting synthetic growth hormone directly, a secretagogue signals your brain's pituitary gland to secrete more of your own natural growth hormone.
Oh.
They focus on systemic metabolism, fat loss, and overall anti-aging. But they are far inferior to BPC-157 when it comes to direct localized wound healing.
Right. And what about MK-677?
MK-677 works similarly by increasing systemic IGF-1 levels and bone density, and it happens to have a much higher amount of human data backing it up.
Which is reassuring.
It is, but again, it's a systemic growth signal, making it less effective for the targeted rapid tendon or ligament repair that BPC-157 specializes in.
Let's talk about the practical application of this, specifically the dosing logic, because the data mentions very precise microgram dosing.
Yes. The standard protocol for muscle and joint recovery ranges between 250 and 500 micrograms, typically administered once or twice daily.
Okay.
A common baseline is roughly 5 micrograms per kilogram of body weight, and the cycles usually last anywhere from 4 to 12 weeks, depending entirely on the severity of the injury.
So a minor strain might just need a short 4-week cycle.
Exactly, while chronic tendinopathy might require the full 12 weeks.
Okay, but human nature says if 500 micrograms is good and it heals my Achilles in 6 weeks, then 1,000 micrograms must be twice as good and heal it in 3 weeks.
People always think that.
Right. Why not just blast the dose and cut the recovery time in half?
Because biological systems simply don't work on linear math. Pumping in higher amounts does not yield faster results due to a phenomenon called receptor saturation.
Receptor saturation.
Right. Think of it like a game of musical chairs.
Yeah.
If a specific tissue has 100 receptors on the chairs and you introduce 500 molecules of BPC-157, all the chairs get filled instantly.
The signaling pathway is fully activated.
Exactly.
And if you introduce 1,000 molecules...
The extra 500 molecules have nowhere to sit. The receptors are completely saturated. You are just wasting the compound, straining your body's clearance mechanisms, and potentially increasing the risk of adverse side effects.
But some more is definitely not better.
No. If we connect this to the bigger picture, this biological limit is exactly why advanced athletes utilize stacks rather than pushing megadoses of a single compound.
Oh, right, because different compounds target different pathways, you're filling up different sets of chairs?
Precisely the point. Instead of doubling the BPC-157, an athlete might run a normal dose of BPC-157 for local blood flow, combine it with TB500 to maximize cellular migration, and add oral collagen peptides to provide the actual raw materials for the structural repair.
A multi-pronged approach.
Right. They might add omega-3s to manage systemic inflammation and magnesium for muscle relaxation. It's about creating a comprehensive multi-pathway repair environment, not just forcing one biological lever until it breaks.
We really need to talk about what happens when you start forcing biological levers, because this brings us to the severe caveats, the red flags.
And there are quite a few.
Yeah, we've spent a lot of time on the miraculous-sounding benefits, but the data is extremely clear that this is not all rapid healing and sunshine. First off, legality and approval.
This is a critical reality check. BPC-157 is not FDA approved for human consumption.
Wow. Okay.
It is strictly categorized as a research chemical. Furthermore, if you are a competitive athlete, it is definitively banned by the World Anti-Doping Agency, WADA.
So no taking this before the Olympics.
Definitely not. It is a prohibited substance, and athletes face severe penalties, including multi-year suspensions, if it's detected in a screening.
That's a massive red flag. And then there are the physical side effects. Even though its structure is derived from something natural in our bodies, isolating it and injecting it at concentrated doses causes disruptions.
Immediate side effects can be quite disruptive, yeah. Users frequently report gastrointestinal distress, primarily nausea or cramping, especially with oral administration.
Wait. If it heals the gut, why would taking it orally cause stomach cramps or nausea? That seems entirely backwards.
I know, it sounds counterintuitive. It has to do with rapid shifts in localized blood flow and motility.
Okay, how so?
When you introduce a concentrated peptide that forces sudden vasodilation in the gastric lining, the abrupt change in blood pressure and cellular activity in that specific tissue can trigger acute cramping or nausea.
Just because the body is shocked by it?
Yeah, the body struggles to adjust to that massive influx of blood, even though the long-term cellular effect is protective.
That makes sense, actually. The system gets overwhelmed. What about the other side effects?
Well, we discussed how it modulates nitric oxide to widen blood vessels systemically, right?
Right.
Those rapid vascular changes and subsequent drops in blood pressure can cause temporary throbbing headaches and bouts of dizziness. Many users also report significant fatigue and lethargy in the hours following administration.
Really? Just from the blood vessels dilating?
Simply because their cardiovascular system is working hard to adjust to the altered vasodilation.
The thing that really caught my eye regarding the risks, though, is the major long-term unknown.
Yes, the angiogenesis issue.
Exactly. We spent the first half of this deep dive talking about how BPC-157's ultimate superpower is angiogenesis, growing new blood vessels rapidly to heal damaged tissue.
Right.
If it's doing that systemically, what happens if it starts building a robust new blood supply for tissues or cells in our body that we absolutely do not want to grow, like mutated cells or tumors?
You've highlighted the exact reason why this compound is not considered safe for prolonged continuous use.
It's a real concern, then.
A massive one. The promotion of unwanted angiogenesis is a profound theoretical risk. If you have aberrant precancerous cells in your body, which many people do without knowing, providing them with a rich, new network of blood vessels to feed on is the absolute last thing you want to do.
That is legitimately terrifying.
It's a risk factor that cannot be ignored. And the stark reality is that we have a severe lack of longitudinal human safety data.
Because it's not FDA approved.
Exactly. The safety profiles we currently rely on to assess risk are almost entirely based on short-term animal studies and anecdotal reports. We do not have decades of lifelong human observation to tell us what continuous administration does to human cellular growth and vascular development over a 10-year span.
We're basically flying blind long term.
Yes. This is why experts in the field strongly recommend limiting any use to a maximum of 12 weeks, followed by an equal or longer rest period.
Giving the body a break.
Right. The body needs time to return to natural hormonal regulation and clear out any abnormal cellular growth before you push those pathways again.
So what does this all mean? We've covered a massive amount of ground today.
We really have.
BPC-157 is undeniably a fascinating, powerful signaling molecule. It acts as a biological city planner, accelerating tissue repair, laying down new blood vessels, and neutralizing excessive inflammation.
It's incredibly potent.
It has incredible potential for healing everything from torn knee ligaments to damaged gut linings. But It is unequivocally not a magic muscle builder.
No, it won't do the lifting for you.
It won't give you massive biceps directly. It is completely unapproved by the FDA for human consumption, banned by WEDA, and carries very real, poorly understood long-term risks regarding unwanted blood vessel growth.
For you listening, it is vital to remember that while the idea of Wolverine-like healing is incredibly tempting, especially when you are frustrated in dealing with a stubborn, chronic injury that just won't go away, a research peptide cannot and should not replace the foundational pillars of recovery.
Right. You can't just inject your way out of bad habits.
Exactly. You still need structured, progressive physical therapy. You still need proper nutrition. You still need adequate sleep. BPC-157, even in the most wildly optimistic clinical views, is an adjunct to optimization. It is not a replacement for doing the actual, unglamorous work of recovery.
I want to leave you with one final provocative thought to mull over.
Oh, let's hear it.
The data notes that BPC-157 interacts with our physiological repair mechanisms, in part by making cellular receptors for other growth hormones more sensitive to the signals already in our blood.
Right, the receptor sensitivity.
Think about that for a second. If a compound, which is essentially just a synthetic derivative of protein floating in human stomach acid, can fundamentally alter how our body's cells listen to our own natural hormones, how many other naturally occurring human proteins are currently sitting in our bodies, entirely undiscovered, holding the keys to rapid biological repair?
It's staggering to think about.
We might just be scratching the surface of what our own biology is truly capable of.
It really makes you wonder what other master switches for healing are hiding in plain sight within our own chemistry.
It sure does. Thanks for joining us on this deep dive. We'll catch you on the next one.